All right, folks. Thanks for coming. Today we're gonna continue with polynomials. Okay. Well, this will be the conclusion of polynomials. Yesterday I couldn't squeeze the application of rational expressions in the video I did yesterday. It was getting too long, so my initial plan was to include it, right? To include the applications of real world applications of rational expressions in the video I did yesterday, but I couldn't do it. It was getting too long, you see. So today let's concentrate on applying rational expressions to real world situations. Before we continue, please subscribe to my channel, like and share this video. If you have any questions or comments, leave them under the video. I will get to them. Alright, as I was saying, my initial plan was to conclude this stuff yesterday, but I couldn't. The video got too large. I solved too many problems, but it's always good. It's always good to illustrate concepts with a lot of problems. That way students can understand what is going on. But here I'm gonna solve a bunch of problems, application problems today. Okay, that's all I'm gonna concentrate. It's gonna be from different areas. You see, I'm gonna deal with numbers. What happens when you have a fraction and you tweak it? You add something to the numerator, you add something to the denominator, and then you equate it to what they call equivalent fraction. Okay. Equivalent rational expression, and then you solve, you see. So everything will land dealing with rational expressions would be used to solve real world applications. Okay. Also, stuff we'll learn from the past will be included. Will be used. We apply stuff we'll learn from the past. Whenever you solve a problem, you use whatever you know. Whatever skill you have, you bring it in. Whatever technology you have, you use it to solve the problem. That's what this is all about. So we're gonna deal with numbers, how to modify numerators and denominators. If we modify it, then what happens? Stuff like that. And then we're also gonna solve problems about distances traveled. In a car traveled distance, two cars going opposite direction, the same direction. And also we're gonna solve the what they call rate problems, right? Rate of change. When you talk about rate of change, time is involved. So we'll get to that later on when we get into calculus. But we're building this stuff up until we get to calculus. What normally happens, we'll solve problems using algebra. But when you go to calculus, you see a better way to handle the problem, you see. But not everybody, studied calculus. So algebra can be used to solve the problems too, you see. So, but calculus is a more beautiful way to solve many problems. But we'll get to that. We're building up to it. Also, we're gonna solve problems involving work. Like when you go to work, how many hours you worked, what is the rate of pay. Also, let's say two people start doing the same job. One is working slower than the other guy. One is taking 2 hours, the other one is taking 1 hour to complete the same job. If you put them together, what's gonna happen? When are they gonna finish it? How much are they gonna be paid? Stuff like that. We're gonna deal with problems like that. Okay. So I will give you example. I will give you general guideline how to solve world problems, real world problems like this. Generally, it's the same as we did in the past. Linear equations, quadratic the applications of linear equations, the applications of quadratic equations. It's the same idea, So I'll give you general guideline how to approach it. And then I will solve a bunch of problems, like I said, from different areas. Okay, so this video may not be as big as the videos we saw yesterday. Alright, so it may be about 1 hour, 2 hours, 3 hours, I don't know. So, but anyway, so let's go. I'll show you some examples. Alright, before I show you examples and then go and solve problems, let me give you a general guideline, okay? a general guideline how to approach word problems. Okay, this is just like a problem solving technique or method when you see problems described in words. Okay, there's nothing to be scared. You just have to read it carefully. Read the stuff carefully, pick out the variables, what is known, what is unknown, and then you sign a variable, and then you write an equation, and then you solve. After you solve, if they want you to check, you check. Okay, so the first thing is you read. You gotta read it carefully, man. Read the problem carefully. Yeah, read the problem carefully, okay? Read the problem carefully. Okay? What that means is, as you read it, note the given, whatever information is given, note the given, and note the unknown. The unknown, okay? There's always unknown that they want to know. You want to find. They give you some data, some numbers, and then they say find something using the data. That's all. So read carefully. Note what is given to you, the information given to you. Note the information they want you to find. Okay. And then secondly, then you assign a variable. Okay. We discussed variable in one of my videos, well, several of the video. Assign a variable to the unknown. Okay, once you discover the unknown, you assign a variable to the unknown. This is very, very important step. Assign a variable to the unknown, because then once you assign a variable to the unknown, then you use the knowing to find the unknown. Okay, and then after that, write an equation. Design an equation, whatever you want to say. Write an equation, okay? Write an equation using knowns, and then that one unknown. There's always one unknown they want you to find. Sometimes several unknowns. Okay? Using the knowing and the unknown, okay? Usually the unknown is in form of a variable mixed up with the knowns, okay? And then you solve. After that, you write an equation, then you solve it. After you solve it, then you interpret, okay? You interpret it, okay? You solve it and then you interpret it. That's all. You solve. You can say number 5, interpret. That's okay. It doesn't matter. There are different. You interpret, okay? Sometimes that number 5 is not there. It's not required, because once you solve the problem, it's there. But in some occasions, you gotta interpret, man. You gotta interpret that way people can understand what you did, okay? So these are the general steps. The most important one, you gotta read the first one. Read it. Carefully read it carefully, understand the knowings, what are the numbers given, and then understand the unknown, okay? Look for the relationship between the knowing and the unknown. Once you get that, then you assign variables, or 1 variable, 2 variables. You just assign a variable, and then you write an equation, okay? And then you solve. That's all. So let me give you some examples. Okay. So I'm gonna show you a couple of examples of the nature of the problem we're gonna be dealing with. Okay. Here is the first example there. You see what it says? This is example 1. It says, when the same number is added to both the numerator and the denominator of the fraction 2/5, the result is equivalent to the fraction 2/3. And then it says, find the number. Pick up on that. When the same number is added, right, to both the numerator and the denominator of the fraction, that the result is that, okay? So pick up on that. This is not a very difficult problem. I started this that way. You can see you can understand what I told you, listed what I listed up there, how to solve this problem. One, read it carefully, make sure you understand it. While you're reading it, note the given and note the ungiven, okay? And then once you understand what is given, what is not given, then you assign a variable, right? Assign a variable to the unknown quantity. You assign a variable to it, right? Because with that variable, then you can find the quantity, okay? And then you write an equation with the variable that represent the unknown, including the known. You mix it together with the variable the way it's described in the problem, and then you write an equation, and then you solve. After you solve, you try to interpret the stuff, okay? So let's read this again, and then we'll see how we can solve it, okay? It says that when the same number is added to both the numerator and denominator of the fraction 2/5, then the result is equivalent to the fraction 2/3. Then it tells you to find the number, see? So there's a number they're seeking for, and that number is added to the fraction, the first fraction, and then it's equivalent to the second fraction. Notice I explained to you earlier on the other video that the fraction 2/5 is a polynomial. It's a rational expression, right? 2 is considered a polynomial. 5 is considered a polynomial. All right. The other fraction, 2 is considered a polynomial, and 3 is considered a polynomial. So both of them, even though we say fraction, they are rational expression. Okay. All right. So you start by saying let. You're looking for some number. The number is added, right? You start by saying let x be the number, okay? The number added. Let's x be the number added, okay? And then once you say that, then you do what they said the x did. They say x is added to both the numerator and the denominator of the fraction 2/5. What does that mean? Well, they said that you have 2 and you have 5. This is numerator. This is the numerator. This is denominator. They say x is added to them. You add it right there. You add to both of them. Like that's what that thing is saying. It's added to both numerator and denominator of the fraction. It's here, right? Okay. So once you add that thing like that, and then we'll keep reading, what does it say? The result is equivalent to the fraction 2/3. So what that means is you added, then the result is it's the same thing as 2/3. That's what they said there. The result, in other words, you equate it to 2/3. Basically, that's the you form this equation. Okay, you form this equation, and then you solve. Okay, see, once you form this equation, it looks familiar. There's really nothing to reduce, but what we need to do, let me explain something to you. You should know this. If you have a quantity, let's say you have a polynomial, you have px over qx, okay? Noting that qx is not equal to 0, okay? And you equate it to a quantity. If you equate it to, let's say, a over b, all right? I think I explained this when I did arithmetic. In arithmetic video, I explained it. I think I also explained it very other places. When you equate it, to solve for one of them, you have to cross multiply right there. Cross multiply like that, okay? It becomes like this. You can say, see, px, okay, times b. See that? Let me take more space. Hang on, I need more space. So we'll do it over here. You cross multiply. Cross multiply means you do this. You say px times b is equals to qx, okay, times a. You see that, right? You cross multiply. Okay, so if you cross multiply like this, if this is given, that is given, that is given, then you solve for that. That is not given. Let's say this is not given. So any of them that is given, you can solve for. If this is not given, you can solve for it. If this is not given, you can solve for it, okay? So that's the idea. That we're going to use this idea in solving that problem, okay? So let me clear that. I'm just trying to explain to you. That way you understand what I'm doing. Okay, so now we'll cross multiply because there's nothing to reduce. You cross multiply, then you have 2 plus x times 3. See that? Equals to 5 plus x times 2. You see it, right? And then you simplify. What do you do now? You say 2. Let me see. Yeah. You say 6, multiply things out, plus 3x is equals to 10 plus 2x. You see that, right? Alright. You move the like. Remember we did this when we did linear equation. Whenever you solve problem, move the variable to one side and move the constant to the other side. It doesn't matter where you move it, but I like to move my variables to the left. It really doesn't matter. So you keep 3x here, you bring over 2x. It becomes minus 2x equals to 10. 10 stays there on the right hand side. You move over 6 and it becomes negative. Whenever you move something from one side to the other, you change the sign. That's all we did. I covered that in the past. Just start watching my videos. You will learn all this stuff. Okay, because you see, let me tell you something. You know, some teachers or Americans say, okay, you have 6 plus 3x equals to 10 plus 2x, and then they say subtract 6 from the left. You say you take away 6 plus, then you say plus 3x. Okay, and then you add, if you take away 6 from here, you add it over there. You do 10 plus 2x plus 6. You see what they're doing? No, you take away, sorry. If you take away, then you take away. Sorry about that. Whatever you do on the left, you do on the right. See, that's the idea. It's okay, man. If that works, that's fine. Plus 2x, you take away 6 here too. And then 6 drop off of here, then you have 6 there, then you have 3x equals to 10 plus 2x minus 6, okay? And then you take away that. Now you do another take away. You take away that. You see what they're saying? You take away 2, so you do 2x minus 6, you take away 2x. And then over here you take away 2x. Then it becomes plus 3x, okay? So that's the way they do, but I don't do it that way. If that helps you do it. I just move things around. You move 6 to the right, it becomes negative. That's the same thing they're doing. See, they move this from here to there, but they want to say take away there, So that's the same thing they're doing. I don't have time to be taking it away and doing all that, I just want to save time, okay? But if that makes you happy, do it that way. All right? Okay, so we'll move things around. Let's see. And then we'll simplify. Then we'll have x here equals to, we'll simplify the right hand side equals to 4. And we're done. So the number they're looking for is 4. Okay, so if you go back, you can check. If you do it right, your teacher might want you to check. It says that when the number is added to, when the same number is added to both the numerator and denominator of the fraction 2 over 5, the result is equivalent to the fraction that. So let's do it. So you have the fraction 2 over 5. Let's say you you say added, right? When the same number is added to both, so you add 4 because we got 4, okay? What happens? Simplify that. You say 6 over 9. You see? Divide that. Simplify that. What do you get? It will be 3. No, 2. 3 will go both of them. Actually, let me do it right because that's what we're dealing with over here. You can write this up to you. Write it as this 2 times 3 and 3 times 3. Okay, this cancel that. You get 2 over 3. That's it. That proves that's it. 2 over 3. So if that makes you happy, check. But I know I did it right. That's the solution there. So understand what we did, man. Read it, go through it, understand it, and then we're gonna solve a bunch of problems like this. And let me say, before I leave this problem, let me say something. Most of the problem we're gonna solve is like messing with stuff like this. Once you set up the problem, right? Once you set it up, it's gonna be the same thing. You notice it's gonna be the same thing. You have some kind of fraction, okay, some kind of rational expression. You did something to it. You multiply this here, and then you get something, or you subtract that there. You get something, okay? That's what we're gonna be dealing with. So that's why I want to start with this kind of problem, okay? But I'm gonna show you other problems where we're gonna encounter. I will show you the other problems. So let's go. All right. Now look at the second example. It says a river has a current of 3 miles per hour. A boat in the river takes as long to travel 12 miles downstream as to travel 8 miles upstream. What is the rate of the boat in still water? Yeah, what they mean by still water, in case you haven't seen any problem like this, it means there's no wind. No wind is blowing to the boat, no tornado, no nothing. The water is just very quiet. The weather is quiet, the boat is floating according to whatever is controlling the boat, the engine, or they're using what do you call that, a row, so that's what they mean by still water. No unnatural weather condition, you see, pushing the boat around. The boat is just moving, or moving up or moving down. So this kind of problem is called, they call it rate, distance, and time problem, okay? So, that's what physics, they deal with that in physics, you see. So, we also deal with it in mathematics. Even calculus. When we get to calculus, you see, calculus is about the rate of change, you see. And the rate of change is time is involved, distance is involved, you see. So, generally, right, let me show you, generally. I'm going to show you what is going on, and then we'll solve the problem. Generally, right? Generally, there is a relationship between let's see, distance, rate of movement, okay, and time, because all those things vary as you move. You move, you're covering distance, you go in a certain rate, and then time is moving, okay? So, what normally happens is, let D equals to distance, okay? And let R equals to rate. And the T equals to time, okay? It's generally knowing that rate is equals to, it doesn't matter which one goes first. Rate is equals to distance, okay? Well, I'm sorry, I don't have to write it. I don't have to write it since I already abbreviated it. Rate is usually knowing is equals to distance D over time, okay? So it doesn't really matter how you write it. You can also say distance is equals to, that's why I say you cross multiply. Distance can be written as rate times time. You see? And time can be written, you see? Time can be written as distance over, distance over rate. See what you're doing there, you cross multiplying. You cross multiplying things, that's all. You cross multiplying things there, that's all you're doing. You see? From here, or it doesn't matter whichever way you come from. Look at it. You cross multiplying. Let me change the ink. What you're doing there is, you say, I'm going to capitalize it, rate equals to distance over time, okay? And then you can put that 1. Then you can cross multiply like that. So basically you cross multiply, you say distance times 1 equals to rate times time, you see? In case you're looking for distance, you write it like that, then you put the variable, the constants here, you solve, okay? But let's say you're looking for time. So you write it like that, then you say D divided by R equals to time. See? That's what we did there. Okay? But if you're looking for R, then you say D divided by time is equals to R. That's what we did here. That's what we did here. See? So, it's a question of chicken and egg. Which one came first? Is that one came first or this one came second? It doesn't matter. Just remember one. If this is so easy for you to remember that. From there you can find the other two. Okay? So this is the general introduction. So let's solve the problem at hand. So I just want to give you general introduction about rate, distance, and time. Those are variables that changes with one another, you see. So now you see let's read the problem again. It says a river has a current of 3 miles per hour. A boat in the river takes as long to travel 12 miles downstream as to travel 8 miles upstream. What is the rate of the boat in still water? Alright, so you say let X be the rate of the boat, okay, in still water, whatever. Alright, note that we'll have two situations going up there, downstream and upstream, okay? So let's do downstream. So you use what you are given. Downstream, like I told you earlier, when you're going downstream, the current is carrying you, it's pushing you forward, okay? So it will be X plus the rate of the current, which is 3. Okay, and then you say the boat takes as long to travel 12 miles downstream. So the distance there, downstream, is D equals to, this is rate. Is D, distance, I'm sorry. Let's be a little cleaner. Distance is D equals to 12 miles, okay? Okay. And then upstream. You see, let's do upstream. Upstream, it says the rate, of course the rate will be equals to X minus 3 because the current of the water is pushing against the boat. Alright, so the rate is that, and the distance is giving us 8 miles, okay? Alright, so to find the rate of the boat, in still water, what you need to do, remember I just showed you the equation of that thing there. I told you rate is equals to distance over time, okay? Alright, so but see, we'll have rate and we'll have distance, okay? So we don't have time, but it says it takes us, you see what it says, it takes as long to travel upstream as to travel. That means the time is the same. So then we're gonna equate the two times. So the time for downstream is d over rate, okay, and the time for upstream is something t equals to d over rate, okay. That was from the stuff I showed you before. You're just using that, okay, and then we'll have this. They will have this data here. We'll plug it in there. We'll have x. I'm sorry. We'll have we'll have rate, and then we'll have distance. Okay. Then we'll have let me see, 12 over x plus 3 here, and then over here we'll have 8 over x minus 3. Okay, basically because they said this is the key there. It takes as long to travel downstream as to travel downstream. So you equate those two. 12x plus 3 is equals to 8x, because the time is the same. See, don't forget this is time. The time is the same, okay? Alright, so you equate those things and then you solve. You see that, right? Once you equate it, there's really nothing you can do. You have to cross multiply. You cross multiply, then what do you get? You get 12 times x minus 3 equals to 8 times x plus 3. Alright? So you multiply them out, you have 12x minus, what is that, 36 is equals to 8x plus, what is that, 24. Okay, you move the same variable to the same side. You have 12x minus 8x equals to 24 plus 36. You see that, right? And then you combine. What do you get there? You get 4x is equals to, what is that? That's 50, that's 60. You see it, right? Okay, so you say x is equals to 60 divided by 4. What is that? You see what I'm doing, right? Okay, so that's 15. All right. So that's you remember what x? That's the rate of the boat. So that should be. Sorry about that. That should be. X should be equals to 15 miles. 15 miles per hour, okay? Because that's the word we're using. We're using miles. We're using miles and mile per hour, miles here. Okay, so it should be 15 miles per hour. That's because it's the rate, okay? So we'll leave it like that. All right, let's look at example number 3. It's about work. It says you can mow a huge lawn in 4 hours. This means after 1 hour you will mow 1 over 4 of the lawn, right? You can mow a huge lawn in 4 hours. So after 1 hour you can mow. Okay, that's fine. I don't know if that's necessary true, but it's okay. And then it said after 2 hours you can mow 2 over 4 or half of the lawn, and so forth, okay? Now there's idea here. You just have to use it as an abstraction to solve problems that is work related, okay? The idea is that it's similar to the idea of remember we said we said in example 2 that rate is equals to a distance over time, yeah? Okay. And then that means that rate times time is equals to distance. Remember we said that, right? So that's a similar idea here. It's a similar idea here. the most important idea, look at this. It says that if a task or a job, if a task can be done or completed, okay? If it can be done or completed in time t, okay, then the rate, okay, the rate of work, pick up on that, the rate of work, okay, is rate equals to 1 over t. That's basically what is going on here, okay. See up there, you can do the amount of work you can do in 4 hours is 1 over 4. Notice that the 4 there is t, and the work you can do in 2 hours. In 2 hours, you do you do half of the work, right? Because the whole work can be done in 4 hours. You notice that, right? Okay. So that's one thing to keep in mind. Another thing to keep in mind, they also have this thing. They said the amount of work done, the amount of work, okay, amount of work done, represent that by W. Amount of work done is like this. W is equals to rate times time. That's the rate you're doing the work and the time it takes you to finish the work, okay? So that's where it's similar to the thing we discussed in the example number 2. So the amount of work you can do is equals to rate times time. Okay, so that's from there you can basically get a bunch of stuff, like you can get rate is equals to work over time, okay? Or you can do time is I'm sorry. Here is rate, not time. Rate equals to work over time, or you can do time equals to work over rate. Okay? So you keep that in mind. You can also see that. You see what it says here? Your huge lawn can be, it would take you 4 hours to complete the work, right? Okay, look at that. If we take you 4 hours, let me see. You can mow your huge lawn in 4 hours. So the time, the T is 4 hours, okay? And then it says after 2 hours, right? Let's look at that. After 2 hours, how much have you done? Well, after 2 hours, right? After 2 hours, right? Then you can say, well, if that's the case, then you're gonna say amount of work done when because you finish is the rate times time, right? So it's work equals to 4R, okay? And then from there you can say in 2 hours, right? In 2 hours, let me see if I know what I'm talking about. In 2 hours, when T is equals to 2 hours, the amount of work you did is let me see, is 2 times rate, right? So that would be W, the rate. You do half of the work. You see that, right? The rate is the rate you're doing the work. You have done half of the work. So make sure you keep all this in mind. It will come to be when we start solving problem, So just remember this one. Okay, once you remember that, you can get that, okay? Just keep that in mind as we solve problem, okay? Okay, here is this is number 4, example number 4, okay? And he says Frank can mow the lawn of a huge lot in 10 hours, alright? And Sam needs 15 hours to complete the same task, okay? If both Frank and Sam work together, how long will it take them both to complete the job? We're looking for how long. That's time, right? The time it would take them. Let T, we can use X, but let's use T. T be the time or hours. Time it will take. It will take them both, okay? Take them both to complete the job, okay? Alright. Now, notice what I said up there. I said up there in example number 3. This thing is a little bit screwy. Remember that I said that the time it takes, the rate of work for a job, right, is R equals to 1 over T, okay, which is the same thing as rate times time equals to 1. That's the time it take to complete one job, okay? And remember that we also said that the work done, W, okay, W is equals to rate times time. You see, work done, W, you see? Okay, so this is one job they did, okay? Now, we are told that for Frank will complete the job in Frank's rate is 1 over 10. Okay, 1 over 10. Let me see. He will complete the job in 10 hours, right? So yeah, see right here. And then we're told that Sam will complete the job 1 over 15, okay? That's that right there, okay? Alright. And then notice that they're doing one job, right? So basically, it's one job they're both doing. So rate times time is equals to 1, like we said here, okay? So we're looking for the time they will use to finish, the time they will finish the job. That's what we're looking for, okay? Alright, so if we would do, let me see. If we combine their rate, okay, then their rate, the combined rate will be 1 over 10 plus 1 over 15, okay? Alright, yeah? Well, yeah, 1 over 10 plus 1 over 15. Now, you know, that's the combined rate, okay? So basically, using this here is saying that 1 over 10 plus 1 over 15 times T, okay? Is we'll finish one job, like that. You see, right? That's what we need to solve. I don't know how else to express this, but basically this is rate times time, okay? This is their combined rate. This is the time we stipulated over here. The time we stipulated, okay? That's their combined time to finish the job, both of them working together. So we'll solve for that. You know, that's what we'll have to solve. So basically you have T. If you push T inside, you get T over 10 plus T over 15, okay? Is equals to 1. You can say 1 over 1, but we'll leave it for now. Okay, we're gonna put them in the same denominator. How do you get both of them in the same denominator? So what do you do? What we'll do is what? So the next thing is the strategy is to have them in the same denominator, right? You remember we did that many times in the other video. So to do that, this is 10 and 15. Basically, the common denominator has to be 30, okay? So we use our trick. If you multiply this by 3, it will give you 30. Then we put 3 here. So we multiply that. If you multiply this by, what is that? 2 will give you 30, okay? So let's multiply that. Sorry, man. What is this, man? Okay, sorry about that. 2 over 2 like that. Multiply that out, 15, okay? All right. So you do that. I'm going to run out of space. So we got 3t over 30 plus 2t over 30, okay? All right, equals to 1. So we'll combine those, it becomes 3t plus 2t over 30 equals to, we can say 1 over 1. It doesn't hurt anything. Let's move this over here. Okay, we'll move it over here. That way we'll have more space. So we'll say, what is that? 5t over 30 is equals to 1 over 1. We'll cross multiply, okay? You cross multiply, what do you have? You have 5t is equals to 30. T is equals to 30 over 5, okay? So t is equals to, what is that? 6. That's it will take them 6 hours, both of them. We take them 6 hours to do the job, man. That's all that is saying, man. You see that, right? By the way, notice that you can check our answer. This is our answer here. You can check it using the reasoning. Reasoning we use. Remember, we use that equals to 1 task, okay? And then we just combine this right here, okay? So if we can. Here's why we can check it. The thing let me expand it properly. Remember we used that. We used let me see what we use. We use 1 over. Sorry, I'm writing with, but it's okay. 1 over 10 over 1 over 15. Okay, multiplied by t is equals to 1 job. Okay, so that would be you multiply that at t over 10 plus t over 15, okay? Is equals to 1 job, okay? Now, look at our t. You put our t in there, you get, this is for Frank, and this is for Sam. Frank, Sam, okay? You see the there, right? So you put t equals, we have t equals to 6. That's what we found. Then you put a Frank is 6 over 10. Sam is 6 over 15. Okay, so the question is it equal to 1 job? Okay, so let's solve that. What is that? That is divide by 2, you get 3 over 5, okay? Divide by 3. Divide that by 3, you get 2 over 15, I'm sorry, not 15, 2 over 5. You get 2 over 5, because 3 will go into 15 5 times. So if you take 3 divided, you get 2. If you take 3 divided here, you get 5. Yeah, that's what I'm trying to say. All right. Now combine those. What do you get? You get 3 plus 2 over 5, because they have a common denominator. What is that? You get 5 over 5. What is that? That's 1. That's 1 job. So it checked out. It's not 2 jobs. There are no 2 jobs, 1 job. Because you see, that means Frank can do that part. What's his name? Sam can do this part. Sorry, Sam can do that part. That's all that is saying. Their part adds to 1 job. You see? I hope you see that, right? You know. So let's solve some problems, man. Okay. Let's solve some problems, okay? Yeah, we got a bunch of problems to solve. Look at this one here. It says the numerator of the fraction 5 over 6 is increased by an amount so that the value of the resulting fraction is equivalent to 13 over 3. By what amount was the numerator increased? Remember, I told you they're gonna give us variation of that first problem we solved. Remember, I told you that there's different variations. They're manipulating the numerator, manipulating the denominator, manipulating both of them. That's all. So all you gotta do, read it carefully, see what they want, and you design the solution. That's all. You see what I'm saying? So, by what amount was the numerator increased? You see, that's your Q right there. The numerator is increased, but it says the numerator of the fraction is increased by amount so that the value of the resulting fraction is equivalent to that. So you select, that's your Q right there. That's your Q, you got Q there. So let X be whatever the amount, be the amount that the numerator was increased. The amount, okay? Numerator was increased. You don't have to write the whole thing. Numerator was increased, okay? You can write it if you want to, but let S be the amount is enough, okay? If that's the case, then read it again. Say the numerator of the fraction, this is increased by amount so this is the numerator they're talking about. The numerator is 5. And the denominator is 6. So they increase it by X, okay? Hang on, I gotta write this properly. They increase that thing by X. They didn't say anything about the denominator, okay? They said the resulting fraction is equivalent to 13 over 3. That's all that means, man. By what amount was the numerator increased? So they're looking for X. That's it. You see? It's not that difficult, man. So you're looking for X. So you let X be the number that they use to increase the numerator, right? So you solve for this. Basically, you solve for the you equate that you solve. So you cross multiply. That's all. You have 3 times 5 plus X is equals to 6 times 13, okay? And then we're going to solve for X. It's 15 plus 3X is equals to, what is that? You see what I'm doing, right? So that's all. That's all you got to do, man. In fact, you can leave that like that if you want. Well, no, you can't. You have to multiply that out. So you can't do it like that. All right, 6 times 13 is equals to 78. That is 78, okay? And then 13 is equals to, I'm sorry, not 13, 3x. From there, I said 3x is equals to 78 minus 15, okay? That's equals to what? Okay? And then you do that, what do you get? You get 63, okay? And then x equals to 63 over 3. That's, you get 21, okay? You get 21 there. That's equals to 21, okay? That's your x there. If you want to check it, you can go check it. Because you see, we got x. So the way you can check it if you want, you can say 5 plus 21. What is that over 6? What is it? The question is 0 equivalent to 13 over 3. I say yes. Divide this by 2, you get 3. Divide this by 2, you get 13. They're equivalent. That's all. They're the same fraction. So it checks out. So we leave that alone and move on to the next thing. Okay, here is the problem number 2. It said this: if the same number is added to the numerator and subtracted from the denominator of the fraction 23 over 12, the resulting fraction is equivalent to this 3 over 2. What is the number? You see what I told you, man? They're playing with the fraction. They subtract here, divide there. That's all. So basically, the same pattern. Okay, sorry. See, the same thing I've been telling you. You just read it and understand it. You move on. Let x be the number. Okay. You're not writing essay. Just write enough so that people can understand. Because we're looking for this number. What did the added number do? If the same number is added to numerator and subtracted from the numerator of the fraction, this fraction here, it says it's 23 is added to numerator, added, subtracted from denominator, subtracted, alright, 12 subtracted. The resulting fraction is equivalent to this. When you say something is equal, it means they're equal. 3 over 2. Okay? So, what is the number? We're looking for x. We'll solve for x. Again, you cross multiply. That's all you gotta do. Okay? If you cross multiply, what do you got? You got 2 times 23 plus x. Alright? Equals to 3 times 12 minus x. That's all. Alright, so multiply things out, remove the bracket, you get 46 plus 2x equals to what is that, 36 minus 3x. See, you move things around, you get 2x plus 3x is equals to 36 minus 46. Okay, all right. We might have to, let me think now. What did I do? We might have to, well, let's see. Let's keep going. If you do this, what is that on the right hand side? Do that right hand side. Okay, what do you get there? You get 10, okay, or negative 10. So on the left hand side, what do you get? That one you're gonna get, I'm running out of space, so that's why I'm doing this. You're gonna get 5x. So basically you say x is equals to negative 10 over 5. Okay, that's negative 2. Why are we getting negative number? Well, let's check it, man. We cannot get negative number, but let's check it. What we gotta do, check it. Let me use red ink and check it. Okay, see what they said. We interpret what they said. This is your interpretation, or check it out, or whatever you call it. X negative 2. Okay, you say if the same number is added to numerator, so 23 negative 2. Okay, because that's what you're doing. You're adding negative 2. And then subtracted from denominator. So denominator is 12. We'll subtract negative 2. Notice what's going to happen. It will be 21 over, that becomes positive. That becomes positive. It will be 21 over, what is that? 21 over 14. Okay. Is that equivalent to that? That's the question. Look at that, 21 over 14. Is it equivalent to that? 3 over 2. I say yes. Because check this, I divide this by 7, divide that by 7. What do you get? You get 3 over 2. See? You see? So they're equivalent. That's how you check that, then you move on. Let's go to the next one. This one says, if the same number is added to both the numerator and denominator of the fraction, that the result is equivalent to that, find the number. Okay, you will dance in the same dance. Let x be the number. Okay, be the number. All right. And then what did he say? He said that number is added both to the numerator and denominator. So 4 over 11 will add x, and we'll add x here. Just do what they tell you to do. The result is equivalent to half. Okay, so we'll solve. Cross multiply. You cross multiply, you got 2x plus, I'm sorry, I'm going too fast, man. You get 2 times 4 plus, I'm sorry, man, I gotta slow down, plus x, alright, equals to 11 plus x, because you multiply that by 1, it changes nothing when you multiply by 1. Okay, so you keep simplifying, you get 8 plus 2x equals to 11 plus x. Okay, you move x over to the left, move 8 over to the right, you get 2x minus x equals to 11 minus 8. Okay, what do you get? You get x equals to 11 minus, that's 3. X equals to 3. See that, right? So we found that. Can we check? Yes, of course. If you want to check, you check it. But I bet you will be correct. So go back to what they said. You can even use this one here. Just you substitute the x there. If 4 plus, what did we get? 3? 4 plus 3 over 11 plus 3. What is that? That's 7 over 14. Okay, is that equivalent to this, to half? I say yes. Look at that. 7 divide, it takes 7 divide 7, you get 1. 7 divide 14, you get 2. So it's, yes, it's the equivalent. So we'll move on. Don't waste time, just run. Move on, man. You don't overthink any problem. If you overthink it, then it catches up with you. Okay, so I don't know what my thing is doing. I want to get that thing out of the way. Right there, like that. That's how I like it, like that. Okay, look at the next one, number 4. It says, if the same number is added to the numerator, subtracted from the denominator of that 5 over 6, the resulting fraction is equivalent to that. What is the number? I told you there's variations of the same problem. You say let x be the number, okay? Be the unknown number. The same thing, okay? And then you say, what did they say? The same number added to the numerator. Okay. You got 5 over 6 is added. Added to the numerator, subtracted from the denominator, subtracted, and the equivalent thing it gives you is that. So when you check, you use that. We're gonna solve that. Cross multiply, you get 10 times 5 plus x is equals to 6 minus x. Because what we're doing, 6 minus 8 times 1, you get the same thing. It changes nothing, man. Okay? So you keep simplifying. You simplify that. What do you get? After you simplify that, what do you get? Alright. So we'll see by checking my security system. If you simplify that, what do you get? You're gonna get let me see. You get 50 plus 10x is equals to 6 minus x. Okay, and then you said move things around. 10x minus plus x is equals to 6 minus 50. Oh Lord. Alright, see that, right? Okay, that would be 11x equals to what is that? Negative 40, I believe it's 44. X equals to negative 44 over 11 equals to negative 4. You see that, right? We got x equals to, you can check. How do we check that? We'll check it here. Let's check it here. We'll substitute it here at the equal. Basically, you're saying 5 minus 4 over 6 minus 4, like that. Make sure you understand how you check that. What is that? You simplify, you get 1 over, what is that there? You get 10. Okay, are they equivalent? Yes, of course they're equivalent. See that, right? So it's checked out. We'll move on. Don't waste time. Just run after you check out. You check out, you run. Okay, before you mess up again. Okay, see, in a certain fraction, the denominator is 5 less than the numerator. You see that? See, they're playing game with what I told you guys. Word, man. You gotta watch out for words. The denominator is 5 less than the numerator. See, they're comparing now. You see what they do? They're comparing denominator and numerator. If 5 is added to both the numerator and the denominator, the resulting fraction is equivalent to this. Find the original fraction, not written in lowest term. What are they saying? Let's find the original fraction. Okay, what do we do? Hang on. Note you will find in the original fraction. You cannot say let x be the fraction. No. You gotta see when they start comparing, pay attention there. The denominator is 5 less than the numerator. You see that, right? So you see, we dealt with this a lot when we were dealing with I think when we dealt with what do you call that, when we dealt a lot with what do you call that, the linear equation, right? Remember when we dealt with linear equations in one variable? We dealt with all this comparison stuff, okay? Basically what this is telling me is we're looking for a fraction. We're gonna find it. It's telling me, we say let x, let's see, let x be the numerator. I'll tell you why. Read carefully. Because they're saying denominator is 5 less than the numerator. So we said let that be the numerator, and then the denominator, then denominator, okay? Denominator is 5 less than, okay, it means x minus 5 is the denominator. You see what they're doing? They're playing game, man. But don't let them confuse you, okay? So basically this setup here, we can set up like this: numerator and denominator. That's why you gotta understand all the terms. Make sure you understand all the terms. If you understand all the terms, you know, they can play game with you. You pick it up quick. And then see what else they said. This is just one sentence. If 5 is added to both the numerator and denominator, the resulting fraction is equivalent to that. So now they want to add 5 here and add 5 here. You know, see, that's why I say you gotta read carefully. And then after they do that, they say it's equals to 5 over 4. Alright? Find the fraction, not written in lowest term. They say you don't have to simplify. That's all that is saying. You don't have to simplify. But you see, we can find the fraction. Watch this. Watch this, man. So we can find the fraction, man. So let's solve that. Let's solve that in there. We'll cross multiply. We say 4x plus. Yeah, we can't leave it like that, but we haven't solved it yet. Okay. We'll cross multiply. 4 times that is equals to 5 times that. The whole damn thing right there. X What kind of nonsense is that? Okay, fine. We'll leave it like that. 5. Okay, you multiply the whole to minus plus 5. Notice that cancels that, man. I don't know if you see that. So basically what you have there is you have 4x plus 20 is equals to, look at that. That cancels that. I mean, there's no other way to see that. 5x, okay? And then what is you get 20 is equals to 5x minus 4x. You see it, right? That's x. So x equals to 20. That's what we got. Now, how do you reconstruct the fraction, though? The fraction is equivalent to that. How do you find the x? How do you reconstruct? See what they said there. You gotta go back. Denominator is 5 less than the numerator. Okay. Oh, by the way, what is x? X is the numerator. Okay. So the way you reconstruct that fraction, x, let x be the numerator. X is the numerator, so x is 20, and then it said then denominator is right there. X, I'm sorry, 20. Sorry, let's clean that up, man. The denominator is 20 minus 5, which is that becomes 20. Yeah, this becomes 20 over 15. Okay, right? That's the original fraction. They say it doesn't have to be reduced term. If you reduce it, it would be like you use a 3. Yeah, well, it can be reduced. Even if you use 3 cannot go into 20. So this is what they're looking for. That's the solution right there. There's nothing else we can do. 20 over 15, okay? I think, okay, I got one more. Let's knock this out. They'll have 2 more. No, I got one more. So let's knock this out and then we'll move on to something else. So we're dealing with them playing with they're playing with numerator and denominator. I told you at the beginning they're gonna have a bunch of they're gonna have a field day playing with it. So let's see what this one said. This one said the denominator of a certain fraction is 6 times the numerator. See again the same thing, like the same thing we did before. 6 times the numerator. If 3 is added to the numerator and subtracted from the denominator, the resultant fraction is going to find the original fraction. The same thing, not written in lowest term. Yeah, you see the same thing. It's like the one with just number 5 was solved. So we'll say because you gotta see what they're comparing. The denominator is 6 times the numerator. So you say let x be numerator, because you see comparing to numerator, okay? And then if that's the case, then it's 6 times the denominator, okay? You gotta see what they're saying. Denominator then is 6 times 6x. That's what that is saying there. That one sentence is packed with a lot of information. And then look at the next one. If 3 is added to the numerator and subtracted from the denominator. So let's do that. 3 is added to the numerator, x plus 3, and subtracted from the denominator. Okay. Well, originally we'll have x over 6s, okay? So we'll say 3 added to the numerator and subtracted from denominator, subtracted right there. The resultant fraction is equivalent to 2 over 5. 2 over 5. That's all they want us to form. Find the original fraction. We'll solve for x. Once we get x, then we can reconstruct the fraction, okay? So let's solve. We'll cross multiply. 5x plus 3 equals to 2 times 6x minus 3. Alright, let's simplify. We'll figure 5x plus 15 equals to, what is that, 12x, see, 12x minus 6, okay? So we'll move things around. Let's do it this way. Let's say 15 here. We'll bring 6 over plus 6. 12 over there. 12x. We'll subtract, bring 5x over. It becomes negative 5x. So we'll simplify. What is that? Simplify all that stuff. This is 21 is equals to, what is that? That is subtract 5 from 12, you get 7x, okay? So x is equals to 21 over 7. What is that? That is, it goes in there 3 times. So x is equals to 3. You see that x is equals to 3. So let's reconstruct that and we use the left side. Yeah, I'm all over the place, man. We can do it here. Let's do it on this side here, on the right side. Okay, let's do it right here. We can reconstruct that stuff in here. So, what is that fraction they're looking for? What is it? Let's go back. The fraction they're looking for, they said this is the numerator right here. The numerator is x. Okay, what is x? X is 3. Okay, x is 3. The denominator is 6x. That's 18. Okay, right? Then what else can we do? There's nothing else for us to do. They say not written in lowest term, because if you write that in lowest term, it will be 3. It will be 1 over 6, but they don't want that, so that's what they're looking for there. So we'll leave it like that. We've done our job. Okay. Look at that. It said the denominator of a certain fraction is 3 times the numerator. If 2 is added to the numerator and subtracted from the resulting fraction is equivalent to 1. What was the original fraction? See, I chose that on purpose. You see where I said the resulting fraction is equivalent to 1. That's why I chose that. I was going to leave this fraction thing, but you notice that 1 is a fraction. I wanted you to catch on that. Why do you think 1 is a fraction? We use the idea all the time, but let's solve the problem. The denominator of a certain fraction is 3 times the numerator. We say let x be numerator. See, you know the routine now, right? Because they're comparing denominator to numerator. They say denominator is 3 times the numerator. So now, if that's the numerator, then denominator, okay, according to what they say there, denominator is 3 times, okay, 3x. If 2 is added to the numerator, separate from the denominator, then okay. So it says if 2 is added, so this is the numerator and this is the denominator, okay? It's saying 2 is added to the numerator, 2, and then subtracted from denominator, 2, subtracted, okay? The resulting fraction is equals to 1. Where do you think they call 1 a fraction? Because remember, we always do 1 over 1. That's a fraction right there. This is the same thing when you talk about what I call the rational number. Rational number are integers, right? Integers like this. This is an integer 4 over, let's say, over 21. This is a rational number. But notice that 4 is a rational number. Why? Because 4 can be written as 1 over 4. 4 over 1. And 21 is a rational number because 21 can be written as 21 over 1. You see that, right? Because if you write it like this or like that, it changed nothing. But it's still a rational number. That's the idea here, you see. So, but anyway, let's solve our problem. I clean this, we'll solve our problem. I want you to make sure you understand that. In case you see that somewhere, don't get confused. 1 is a rational number. Any integer can be a rational number, see. So, but anyway, they give us that. So now we'll cross multiply. We'll get x plus 2 equals to 3x. Let me clean. I made a mess. Okay, clean that up. Okay. So that is equals to 3. You cross multiply because 1 is on the other side, it's changing nothing. Okay. You do like that, then you get, what is that? You say 2, bring 2 from the right side over here. It becomes plus 2, 3x. Bring this over, x over to the other side, it becomes negative x. So you simplify, what do you get? You get 4 is equals to 2x. Or you say x equals to 4 over 2. That is 2. So that's what we got for x. So once we get that, what is the equivalent fraction? Okay, we'll reconstruct that based on what we found right here and right there. Okay, so we'll have the original fraction is x equals to 2. It will be 2 over, denominator is 3x. It will be 2 times 3 in the denominator will be 3 times 2 will be 6. That's what they're looking for, man. You don't have to, they said don't reduce it. That's what they're saying. You don't have to reduce that. If we don't reduce that, that's what it is right there. There's nothing else really we can do. We dealt with the problem, we solved it, okay? So the original fraction is that, okay? So let's go to the next one. I wanted to show you that. Oh, actually, let me see. Is it equivalent? The question is it equivalent to 2 though? I mean to 1. Well, let's see. You divide that out. You divide that out. Well, you gotta use this over here. Okay, that's the fraction. Is it equivalent? Well, we'll see it's 2 plus 2. Okay, because you see the equivalence is here. That's the where the equivalence is. 2 plus 2, and then what is that? Okay, 3x is 6 minus 2. What is that? That's 4 over 4. And that's equals to 1. Yeah, it's equivalent, right? Equivalent to that. So, but anyway, that's what they want. We'll move on, leave it alone. So this is number 8. So I picked that on purpose. It said the numerator of a certain fraction is 4 times the denominator, right? If 6 is added to both the numerator and denominator, the resulting fraction is equivalent to 2. What was the original fraction? See, I told you, 2 can be a fraction. Anything can be a fraction. Because you can put 1 beneath it. That's why I chose this. That way you understand that. Let x be. Now they're comparing the denominator to something else. Be denominator, okay? See? So this problem is actually good. Because we were using the numerator all the time. So they say x is the denominator, then they say the numerator is 4 times. 4 times the denominator. So numerator, okay? Then numerator is 4x, okay? That's all that is saying. If 6 is added to both numerator and denominator, the result fraction is equivalent to 2. Okay, 6, well, we got x, well, I'm sorry. You gotta do it right. That's the denominator, man. Denominator. So this 4x is numerator and this is the denominator. Then it says, what did it say? 6 is added to both. Plus 6 plus 6. The resulting fraction is equivalent to 2. You see it, right? You see, actually 2 over 1 if you want to. So cross multiply, what do you get? You get 4x plus 6 is equals to 2 times x plus 6, okay? Okay, so let's do the right hand because we don't have a lot of space. We're going to run out of space. We'll simplify that. What do we get? 2x plus 12, okay? So then we'll move things around. We say 4x minus 2, we'll bring that over. Okay? Equals to, we'll take that to the right side. Equals to 12 minus 6. Simplify, what do you get? You get, see, 2x equals to 6. X equals to what? 6 over 2, which is 3. Yeah, x is equals to 3. See that, right? That's what we got. I don't know what somebody else got, but that's what I got right there. Okay, my stuff is moving. I need to fix that, but I'll fix it. Don't worry. I'll fix it later. I'm going to fix it once and for all. I know how to fix it. So this is our stuff there. Don't worry about that. Don't let that bother you. I'll fix it. Okay, so we got that. Let's say check that out. So we got x equals to 3, okay? How do you check that? We're going to reconstruct the fraction. The fraction now is, remember, numerator, denominator, okay? Fraction is 4. What is that? 4 times 3 is what? 4 times 3 is 12, okay? The fraction is 12 is the numerator, okay? And then the denominator is 3 because x is 3, okay? So you say leave it like that, okay? And then at the equivalent, these are what the equivalence is, okay? Well, and we'll see that 4 times 3 is 12. Say 12 plus 6, and then 3 plus, what is that? 3 plus 6, what is that? That's actually 18 over 9. 9 go in there, you get 2, right? They're not equivalent right there and there. They're equivalent. So we're done with that, we'll move on. Okay, it says 1/6 of a number is 5 more than the same number. What is the number? So I chose this on purpose. So let's see where this leads us to. 1/6 of a number is 5 more than the same number. Okay. We say let x be the number, okay? Be the number, whatever number. Okay. And they say 1/6 of the number is 5 more than. It's comparing the number to itself. So it say 1/6. What is 1/6 right there? 1/6 of the number 1/6 of x is 5 times more than the same number. 1/6 is equals to 5 more than the same number. More than the same. It's equal to, see, pick up on that, man. This is the number, is 5 more, not times, 5 more, right there. What is that? 1/6 of the number, I'm sorry. 1/6, I did it wrong. This is correct, 5 more than the number. Now, what is that on the left? I did it wrong. Where is the 6? 1/6. Actually, 1/6 of the number is like this, sorry. 1/6 of the number is like this, 1/6. X. Basically, it doesn't matter how you write it. It's same thing. X over 6 is equals to that. That's all they're saying, man. So we'll solve that. That's what they're saying. We'll have to solve this equation, okay? So you can even write this as that's a number. Any number can be a fraction. You see, we'll learn from the other one. Write that as 1 over. So you cross multiply. What do you get? You get x equals to 6x plus 5. Simplify. What is that? 6x plus 30, okay? So, minus 30, we'll move the 30 over to the left, and we'll move x to the right. 6x minus x. Okay, so it becomes what? I don't want to waste time writing. So I know that's going to be 5x. So you get 5x equals to minus 30. If I'm making your head spin, just look at it carefully. I'm just moving things around anywhere I want. Okay? So then x is equals to negative 30 over 5 equals to negative 6. You see that, right? Negative 6. That's it. What is that's the number right there. Because you see, how do you prove that? How do you know you're right? You see how you check it. You say 1/6 of a number. What is 1/6 of a number? 1/6 of it is 5 more than the number. Okay, 1/6 is what? It's negative 1. It says that 1/6 of the number is 5 more than the number. So, is that true? 5. Yeah, actually, yeah. Because you remember the Cartesian coordinate, right? This is 0. 1 here, 2, go that side, right? Okay. This is negative 1, then you get negative 6 here. So this is 5 times, it's 5, 1/6 of it, which is that, is 5 more than the number. Yes. Negative 1 is 5 more than negative 6. That's what they're saying there, man. That's what they're saying. We did it right. So let's move on, man. Okay, let's look at the next one. Say 1/3 of a number is 2 more than 1/6 of the same number. What is the number? It's the same idea, but now they made it a little bit tongue twisting. Okay, the same idea. Let x be the number. Okay, however you wanna say. Let x be the number. Okay. So, what are they saying? 1/3 of the number is 2 more than 6 of the number. So what is 1/3 of the number? 1/3 of it. Just follow their sentence. See, every word is packed a lot of stuff in that sentence. Okay, the sentence is very dense, so you have to unpack it. 1/3 of the number. What is 1/3? Right there. 1/3 of x is right there. It says 2 more than 1/6 of the number is equals to, see, is. That's equals to 2 more than plus 2 more than. Okay, 2 more than 1/6. That's it right there. Okay. It's a little bit tongue twisting, but it's okay. So what you can do, you can move similar thing to the left. So we get that can be written, this one here can be written as x over 3. We'll move this over to the left side, okay? We'll get minus x over 6, because that can be written as like that. And then it's equals to 2. You see that, right? So now we'll have to combine the left side. We'll use our trick. We want to get the same denominator, remember? So we'll say, we'll multiply this by 2. 2 times over 2. That will give us 6 in the denominator. That's all. That's all we're looking for right there. So after we do that, what do we have? We'll have 2x over 6 minus x over 6 equals to 2. Okay, and then you get, what do you get? You get 2x minus x over 6 equals to 2. You cross, that can be 2 over 1. You cross multiply, you get 2x minus x equals to 6 times 2, which is 12, okay? And then you get x. Simplify, x equals to 12. You see that, right? That's what we're looking for right there. Once you get x equals to 12, what do they want us to do? Yeah, the number is 12, man. There's nothing else you can do. How do you prove that? Well, we can, I can show you that it's 12 because we can go back. Let's go back. I'm going to use a red pen. Let's go back over what it says. It says let x be the number. 1/3 of a number is 2. What is 1/3 of 12? That's 1/3 means 12 divided by 3. 1/3 of x is 1/3 is what is that? It's 4. You say 1/3 is 2 more than 2 more than 1/6. What is 1/6? 1/6 is 12 over 6. Okay, that's 2. You say 1 is the question. What they're asking is this 2 more than that? Yes. Yes. That's what they're saying here. 1/3, which is that, is 2 more than that. That's what they're saying over here. And I'm saying it's true. It's true. And we're done with that. Make sure you keep looking at it until you understand what they're saying. Well, I'm done with that, man. Okay. Here is number 11, okay? You gotta read it carefully or there will be a mistake if you don't read it carefully. It says a quantity is 3 over 4, is 1 over 2, and is 1 over 3. Added together becomes 93. What is the quantity? Okay, you gotta read it carefully, man. Let x be the quantity, okay? The quantity or the number. Okay, see the way they said it, if you don't pay attention, meticulous attention, you miss something. You see, they say a quantity, that's x, and then that quantity is 3 over 4, which is 3x over 4, and then that quantity they have x like that. Well, I don't want to confuse you. Let's do it the right way. Sorry. That quantity is half, like that, and then that quantity is 1 over 3, like that. All added together is equals to 93. So don't forget the quantity. You have to add the quantity too. The English is a little poor there, but they packed a lot of stuff in one sentence. You just have to try to unpack it. See, they put that there. The quantity itself is x. So we're gonna combine the left side. Okay, so let's any quantity can be written like that. Any quantity can be a fraction, or what they call what is that they call it? Any quantity can be a fraction or a rational number. That's all. Okay, so our target is to have the same denominator. And then it's going to be 12. You see, that's what they have in common there. So we'll start using our trick. 12 times 12 is over 1. So we'll multiply it like that. Okay. Okay. In this case, we'll do 3 over 3. Multiply by that. Over 4. Okay. In this case, we'll do 6 over 6. Multiply x over 2, and in that case we'll do 4 over 4 multiply x over 3. Okay, it's all equals to 93 over 1. Now we gotta simplify that, man. Don't want to run out of space. It becomes 12x over 12, see that, plus 9 over 12 plus 6x, actually it's 9x, okay, 6x over 12, and 4x over 12 is equals to 93 over 1. You add all that, they will have the same denominator. It will be 12x plus 9x plus 6x plus 4x, all equals to 93 over 1. Make sure you get that, man. That's what we need there. Look at it carefully until you understand it. Okay? That's what they want us to do, and that's what we're doing. Okay. All that will add to 31. You will add to 31x over 12 is equals to 93 over 1. You cross multiply. What do you get? When I done, let me take up space here. If you cross multiply, oh Lord, what do you get? You get, let me take a little more space. If I run out, I go to the right. You get, if you cross multiply, what do you get? You get 31x equals to 93 times 12, okay? That's a huge number there. It's kind of a huge number, man. But that's always a trick. You gotta keep your eyes on the ball. Yes. Okay. Don't multiply yet. You say x equals to 93 like that over 31. 31 going into here, you will get 3. So it's 3 times 12. And that's 36. X is 36, man. See? X is 36. That's it. We can check that. You can go ahead and check that. See, if you check it here, you can check it here. If you take 36, right, you start playing all that game they played there. Let me see. Let's check it here. Take 36. What is that? 36 over 1. I'm sorry, over 1 plus 36 times 3 over 4 plus 36 over 2 plus 36 over 3. What is that? Okay. All right. So you gotta deal with that, man. Okay. So one by one you get 36 plus 4. 4 divided that you get what is that? 4 divided you get 9. 9 times. Yeah? What is that? 36 divided by, oh Lord, 36 divided by 4, you get 9. 9 times 3, you get 27, okay? So from there we'll get 27. We'll write 27 right here, 27. And then from this one we get 2 divided that you get 1 and 16, 8. Okay, 3 divide that, you get 1 and 2, 12. You add all that, what do you get? See, you add all that, you get 93. So this is number 93 here. So checked out. Leave that alone. Let's move on. The same thing here, man. See, these problems teach you something. You gotta read carefully because sometimes they make it confusing. Look, I see the same problem, but a lot of different numbers. A quantity. That quantity is included. The quantity is 2 and over 3 is 1 over 2 is 1 over 7 added together. There are 4 things added together becomes 33. What is the quantity? So let's say it came from mathematical pyrus. Let x be the quantity, okay? Let it be the quantity. Then you say the quantity. Let me take more space now. That way I don't mess up. Okay, I should have moved them. It's okay, doesn't matter. So x plus 2x over 2 over 3 plus x over 2 plus x over 7 equals to 33. That's what they're saying over there. See how that little sentence packed with a lot of information. Okay. So this one is a little wacky. We're gonna have to combine them. What do you think would be the denominator we're looking for? It's gonna be 3. What 3 would divide? What 7 would divide? What 2 would divide? That one gonna be a little touchy. See the trick, you can actually you can put over 1, so you don't worry about that one. You can put 3 times 2 times 7. That's 42. So we'll have to reduce everything to 42, man. So even if you divide 42 by 2, would you 21? No. So if you divide 42, 14, okay, 14 will do. 14 is the lowest. No, 3 will not divide 14, so it's 42. So that's okay, let's knock it out. 42 is not a huge number, we can knock it out. So here we do 42x over 42, okay, see the trick there? And then here we do, you gotta be careful. There we do 14 over 14, 2x over 3, like that. And here we do, what is that? We do 21 over 21 x over 2. You see right here we do 7 and 42 is 6. We do 6 over 6 x over 7 is equals to 33. See what we're doing, right? We're just packing up stuff. And then we ain't got no choice. That's what we'll have to do, man. We do like that. I mean, I don't know what else can somebody do. So that's what we'll have to do there. We keep going. Okay. We want everything to come out to 42. So basically, it's going to be 42. Well, we don't have to worry about that, over 42. And this one here going to be 2 times 14 is going to be 28. 28x over 42. And this one going to be, what's that, 21x over 42. And this one going to be 6x over 42 is equals to 33. We do 33 over 1, that's fine. So the whole thing now, the whole down thing, I'm going to go ahead and add them as I go. I don't want to take up all the space. Well, we're not going to run out of space. So everything going to be over 42, okay? All that stuff, we'll add all that stuff on top there. We'll add 42 plus 28 plus 21 plus 6. That's what that means, man. You add all that, you get 97, because they all have x. Okay, 97x, like that. 97x is equals to, right? Is equals to 33 over 1. You cross multiply, what do you get? You get 97x is equals to 33. 33 multiplied 42. Okay, so x is equals to all that over 97, okay? Sorry about that, man. Okay. I'm trying to conserve space. Well, I don't want to confuse you. Hang on. I got to do it properly. Sorry. I'm getting lazy. Okay, so x is equals to 33. 33 times 42 all over 97. You see that, right? Okay. So what do you think we should do? If you multiply that thing out, that's a huge number, man. That's equals to 1386 over 97. I think it will go. Divide that with 97, what you get Oh man, I don't want to deal with fraction, man. I don't think I want to deal with fraction. That thing end up with a fraction. Well, you don't have to divide it. Leave it alone. I think we did it right. That's what you're gonna get. Okay, so that's what we got. That's x. I'm clearing stuff. I didn't mean to. We got that x equals to that, man. I don't want to deal with fractions. I mean decimal. Decimal. I don't want to deal with decimal. All right. So if you take that and put it here, it's gonna give you 33. That's how we're gonna check it, man. Take that huge number. All right. That's x right there. Oh, if you take that and put it in there, it's gonna give you. That's the only way we can do it. Let's check it though. That's a lot of work, man. I'm lazy now, man. That make me do too much work. Too much work. But I think we should check out. If he doesn't check out, then we messed up somewhere. So what we're gonna do? That's x. This is x right here. So 1386. Okay, over 97. That's the first one there. Okay, we'll add it 2x. Jesus Christ. It's 2x. Let me see, yeah. 2x over 3. 2x over 3. So 2 over 3 times 1386 over 97. You see what I'm doing? And then here 1386 over 97. Okay. Times 2 in the denominator plus 1386 over 97 times 7 in the denominator right there. That's the last one. Would all that add up to that? That's the thing. That's what you gotta have to do. So it's a lot of work, man. Notice that all this 10 on the bottom, 3 can go through 1386. 2 can go 1386. 7 divide 1386. If you can get all that done, then the work becomes easy. 1386 divided by 3. Yeah, 3 will go through it. Okay, still a lot of work. I don't know why they're making us do all that work, man. So anyway, so 1386 over 97 is 3 will go through that again. Multiply that by 2. So this one is actually 924 over 97, okay? Okay, keep going. 2 divide that and there. 1386 divided by 2 is that. So that one is 693 over 97, okay? Plus, look at that one. Can 7 go through there? Can 7 whack that thing out? Oh, Lord. They're making us use calculator, man. 86 divided by 7. Yeah, 7 can divide that thing. I'm talking about this one here. 7 divide 1386, you get 198. And it becomes over 97. You see that? They all have the same denominator. So, you add all that. Their common denominator is 97, okay? Add all the stuff on top. 198 plus 693 plus 924 plus 1386. You add all that again. 3201. And divide 3201 by 97. Divide by 97. I'll be damned, you see? You get 33. So we did it. they give us painful task right there. Actually, right here. So if you do all that, you get 33. So all that is equal to that if you're using x equals to that. So we did it, man. Forget that program, man. They make it too hard. Okay, so we'll leave it there. We're gonna find other. Let me find other problem we need to solve. Okay, I put this problem together from various sources. Okay, because I want to demonstrate, how you approach this problem. When one person does a job, taking certain amount of time, then another person does the same job, taking a different amount of time. Okay, then if they do it together, how quickly would they do it? You see this problem everywhere. So this number 13, this problem number 13 will help you understand it thoroughly. Okay, the number 13 contains 3 parts. I put it together that way you can understand this. By the time we're done with it, just observe it, read it carefully, and then see how I solve it. Then you can cover it up, try to solve it yourself. Okay, so basically we introduce another formula. But the formula it introduces will be derived from the one we used before. But I'm gonna show you how to derive it. Okay, I will actually derive it for you. Right, I will derive it for you, and then you're gonna see how I derive it. Okay, that way it will make sense to you. So basically, that thing you see there, this thing here, is derived from what we know before. That thing there, So, but let me read it. It says, show that if it takes one worker X hours to complete a task, and another worker Y hours to complete the same task, then it will take both of them X times Y over X plus Y hours to complete the task together. To complete the same task together. Okay. So let me show you how I derived that. How that can be derived. Okay. Part A is how it can be derived, and then part B and C is you apply that formula up there to solve the same kind of problem. Okay, so what I would do, I think I'm gonna split the page. Let me see. I'm gonna split this page because we need to conserve space. I split it up like this. Okay. That way I try to you force me to conserve space. Okay. So I'm gonna start over here. I'm going to start right here with an A. Okay. I'm gonna derive that thing they want us to derive. See? Do you recall? Yes. That there are a couple of problems above that I said. That if we would let if based on what it says there, based on what it says here, okay, based on what it says here, okay, let's do it this way. Let X. No, actually I can't use X because, let me see, they already use X. Okay, well, let me see, hang on. We use a different variable, that way I don't confuse you. Okay, let T be be the time it will take both of them. Okay, so let T be the time. Okay, you will see the time it will take them both. Okay, take them both to complete the same job, okay? Because that's what we're looking for, to complete the same task, working together. The same task, okay, working together, okay? Just follow me. Follow me carefully, you will understand what I'm doing. This is, T is the time. The time it will take them working together to complete the task, okay? Maybe I should give no, it's okay. The space is enough. Okay, so let that be, right? And then remember the equation I used yesterday. If that is the time it will take them working together, and he say it takes the first person X hours to complete, it takes the second person Y hours to complete, okay? So that means, from what I told you before, that means, remember that formula I showed you is let me see, 1 over X. That's the time the first guy would take, okay? And then let's see, that's the rate for the first guy, well, the time for the first guy, and then the other guy would take like that, and then you multiply it with T, see? And the equal is one job. You remember that, right? We discussed that. Look, I don't remember the number of the problem. Look up, you'll see it. Okay? We derive that from, look up, you see how I described that up there. So you multiply that out, what do you get? You get T over X plus T over Y is equals to 1. You see that, right? Now, we have to solve that. See, basically, this problem is actually very good. It helps you to understand. You remember, when we solve something like this, we have to put, basically what you're looking at there, you're looking at two rational expressions, okay? Two rational expressions with the same numerator but different denominator. To combine them, we have to have the same denominator, remember? So to get the same denominator, we'll have to multiply the entire equation. Remember, we've been doing this, we've done it 200 times. We multiply the same denominator with this, X times Y. You remember that, right? We multiply the whole thing with that. Okay? We multiply the whole equation with that, okay? Equals to 1. We multiply the whole damn thing. Remember, we did that many times in the past, okay? Alright. So let's multiply that out. What do we get? We get, let me see. Yeah, we're trying to derive that thing. We're trying to derive this here. Don't forget that. So keep your eyes on the ball. Okay. So we multiply it. What happens? Because you multiply that, that will give you the same denominator. So let's multiply that out, see? We'll have X, Y times T on the first one over X, okay? Plus X, Y times T on the second one multiplied by Y. And then we'll have, I gotta give myself a little bit more space, man. On there, just move it up a little bit. That way I'm not squished in. That way you can understand what I'm doing. So let's do it this way. Let's give me a little bit more space like that. Okay. Just a little bit more space. And then we'll multiply that. Don't forget the one on the right hand side. We're going to multiply that too. It will be equals to X, Y times 1. You remember? Because we'll multiply the whole damn thing, okay? Now we'll simplify that stuff. Notice that this will cancel that. This will cancel that. Then what do you get? You get T Y here over, no, nothing. That's nothing over because we'll cancel that out. Just give me a minute. We'll get T, because T is time. Y plus T X equals to x, y. You see it, right? You see that, right? That's what we arrived. We were trying to arrive at that. Okay, so notice that we can pull t out. You remember, we've been doing that, done it 1,000 times. We'll pull t out like that. Y plus x equals to x, like that. And notice that we can divide both sides with that to get rid of it from t. Okay, so when we divide, what do we get? We'll get t equals to x, y over y plus x. You see that, right? That's what we're looking for right there. So notice that there's a commutative, it doesn't really matter. Remember commutative law? If you add 2 plus 1, you get 3. Suppose you put 1 and then put 2 to the other side, you still get 3. So we can rewrite that as, I run out of space, man. We can rewrite that, as this. We can write as t equals to xy over x plus y. Yeah, that's what they have up there. You see what they have up there? X times y plus x plus y. You see, that's what we arrived. So we'll solve that. You see that, right? So that's the time it would take both of them to work together. So we can apply that to solve this and that. Okay, so we got it right there. Right there, we got it. You see, so anyway, let's solve the other one. Let's solve now. Let's solve B. What does B say? Read that carefully. It says, if Amy can paint a long wall in 3 hours and Mary can paint the same wall in 5 hours, how long will it take them both to do it together? So that's similar to what we derived over here. Okay. Now notice that what they're saying. You don't have to reinvent the way you use that formula. Let t. Okay, you can just say let t be the time. Okay, the time. Sorry. Let t be the time it would take them. The time. Okay. It will take them to do the task, working together. Okay, working together. So you need to make sure you understand that, because we're stipulating that let it be what it would take them. Then from what we derived over there, we derived it over here. We say, okay, we know that, from what we derive this, x times y over x plus y. And notice that what that means, you gotta understand what that means. This is the time one of them is using. This is the time the other one is using. That's the same time this guy is using, the same time that guy is using. So you need to understand what that formula stands for. Okay, if you're gonna use it, it's their time. The time they're gonna use to do it separately. So we just use that because we derived it. X times y over x plus y. Okay, so that will you see here in this our situation, right? Y, let me see, you can say x. I'm sorry, this stuff is moving around too much. Just give me a minute, let me clean this out, man. I don't know why I'm moving it. I think because of the way I split the page. Here you can say x, choose what do you want to choose. X is equals to 3. Okay, x is equals to 3, y is equals to 5. That's what it's giving us right there. So make sure you know how to use that. Once you do that, then you say the time you will take them together is like this: 3 times 5 over 3 plus 5. That's all that is saying, man. man, we're gonna run out of space, man. We're gonna run out of space. So don't worry, I'll create more space. So you solve that. What do you get? Yeah, I think I can. You know what? I don't want to run out of space. Give me a minute. Let me clean this out. I don't want to run out of space, man, because I gotta make it work. So from what we'll see up there, right? From what we see up there, we have this. Our stipulation is, I say here from the problem, okay? We can choose x equals to 3 and y equals to 5, okay? And then we'll solve t. T is equals to 3 times 5 over 3 plus 5, okay? What is that? That's 15 over 8. That's it. It's nothing you can do. We're done with that. You see that, right? That's what it says, man. That's what it says. This guy, this lady, 3 hours, 5. Yeah, that's what we get. There's nothing else we can do. We're done. Okay, let's look at the second one. It's gonna be the same thing, okay? Because we're running out of space. You see, the number C. I don't know if I should just do it up here. Sorry about that. Well, no, let me conserve space. Let's do C here. See, notice what it says there. C, the time we take them both will be, we use the same formula, x, y over x plus y, okay? And then there, in that case, in that problem T, you read it carefully. Let me read it. A large printer can complete a printing task in 15 hours, okay? The same printing task can be completed by a small printer in 30 hours. How long will it take to complete the same task using the same tool print? You see, the same idea. Make sure you understand that. So that's the formula we derive. The first time is 15 hours, okay? T equals to 15. The second time is what? 30 hours. Basically, that's all. That's all that is saying, man. 30 hours. Okay? You put that in the equation. You get T. That's the time you will take them both. You will take them both 15 times 30 over 15 plus 30, like that. So make sure you understand that, because if you see that problem anywhere, you can knock it out. Even if they increase it to 3 people. I'm going to find a problem. Let's say 3 people do the job. How long will it take them? Let's say 4 people, 5 people, 6 people. So I bet you it's gonna be the same thing. You just have to add more variables. That's all. Okay, so let's knock this out. What is that? So then we can move on to something else. That's 450 over, what is that? I hope you see what I'm doing, man. Don't get confused, man. That's 45, okay. Notice that. Notice what is going on there. 45 times 0 is 450. So if you divide that will be 10. I'm sorry, 45 times 10 is 450. So T will be 10, you see? That's what that is telling me. 45 will go into that 10 times. That's all. So T, the time it would take the 2 printers together to complete the same task, basically that time is 10 hours, okay? Look at the next one. Now, when we see a problem like this, we should be able to knock it out quick. It says Donald can tune up his Chevy in 2 hours, working alone. Jeff can do the same job in 3 hours, working alone. How long will it take them if they work together? Let T represent the time they work together. See? Note that we can use the formula we developed in the other problem to solve this problem, okay? Then we say T is equals to x times y over x plus y, where in this case where x is equals to 2 and y is equals to 3, okay? And then we substitute. We get this t equals to 2 times 3 over 2 plus 3. We simplify. What is that? Is 6 over 5. See that, right? T is equals to 6 over 5, and then basically we're done with that problem, man. Okay, look at the problem number 15. It says a copier can do a large printing job in 20 hours. An older model can do the same job in 30 hours. How long will it take to do the job using both copiers? See, this is the same pattern, man. Okay, note that the formula we developed earlier, T standing for the number of hours it would take both of them to do the job. T will be x times y over x plus y, where, make sure you understand, is where x is the hour it would take the first copier, the y is the hour it would take the second copier. So x is equals to 20, y is equals to 30. Basically, we put in there, we're done. Put it in there and simplify. Okay, 20 times 30 over 20 plus 30. You see that, right? All right. So let's simplify. Okay. So basically, to make it easier for you, leave the numerator for now, and then combine the denominator to 50. You see things will start canceling out. You see that 5 can cancel that into 4. Okay, and then we'll have t equals to, what is that? 4 times 3. Yeah, basically 4 times 3, right? Is equals to, what is that? 12. That's what we're looking for, man. You can't do no more, man. See, once you understand the formula, you know how we derived. Make sure you go back and read how I derived that formula. Once you understand that formula, see how I derived it, you don't have to waste your time. You just plug in. But know what the variables stand for. Note that T stands for the time it would take both the machine or both people to do the job. And then X stands for the time you would take one to do the job. And then Y stands for the time you would take the other one to do the job. Make sure if you understand that, plug in and go. You don't have to waste your time. So let's move on. Look at this one. This one says that a company can prepare customer statements in 8 hours using a new computer. Using another computer requires 24 hours to do the same job. How long will it take to prepare the statement using both computers? So what I want you to catch on is there's different variations of this problem. You can apply it anywhere. Anything else. Anything. That's why I wanted to do a bunch of it that has different variations of application. Do you understand, right? I know, like I said, we can also extend it to 3 things doing the same job 3 different times, or even 4 things doing the same job 4 different times. You see, we can extend it, but I need to make sure, I'll need to hunt that out, and then I'll bring it to you. So this one, you use the same thing we have. See, you use the same thing, the same formula. T is equals to x times y over x plus y. What does T mean? T means the time you would take the 2 computers to do the job. X means the time you would take 1 computer to do the job. Y means the time you would take the other computer to do the job. So you say where okay, x equals to 8, y equals to 24. So then you say T is equals to 8 times 24 over 8 plus 24, okay? Then it's time to simplify. Okay, I suggest you don't You see the numerator, don't multiply it out. Just leave it like this and combine the denominator, and you get that. Notice that 8 can go into 32, you get 4. Notice that 4 can go into 24, you get 6. You see that, right? So t is equals to 6. And we are done with this problem, okay? Okay, we're going to do a couple of more of this type of problems. So, when you need to learn it, you need to refresh your memory. Just come back to the video and refresh your memory. They all use the same formula, okay? Now, look at this. Look at the variation of the same problem. It says a high school mathematics teacher gave a test to her geometry class or geometry classes. Working alone, it would take her 4 hours to grade the test. Her student teacher would take 6 hours to grade the same tests. How long will it take them to grade these tests if they work together? You see, this is a variation of the problem, but it's still saying the same thing. Let t be how long it would take them both to grade, okay? You can start like that. T, the time it would take them both to grade the test. Then t is equals to x times y over x plus y, okay? Where x is equals to 4 hours, y is equals to 6 hours, okay? And then you get t equals to 4 times 6 over 4 plus 6. You see that, right? That's all. Simplify, you get, like I said, leave the numerator like it is. Leave it like it is. We'll see what the denominator turns out to be. It turns out to be, what is that? 10. So you don't have to work with big numbers. 2 go here, you get 2. 2 go here, you get 5. Okay? I mean, we could have multiplied that and then we'll start crossing out. We could have multiplied that in numerator, but it's okay. Alright? So look at that. That is 12 over 5. We can't do no more, man. That's enough. I don't think there's anything else we can do. That we do, man. You leave it like that. If you leave it like that, teacher will understand. You can do take out 5 2 times. If you take out, because it's hours, right? If you take, you can say t is equals to, you say, that's 10, okay, that will be 2.5, 2 hours and 2 over 5. You see that? Like that. 2 hours and a little bit of, it's not quite a half an hour. A little bit less than half an hour, okay? So you see, that's the hour. It's an hour, but don't worry about that. You get the problem, you got it. So let's move on to something else. Look at this one. The same problem, different variations. It says a pump can pump the water out of a flooded basement in 10 hours. A smaller pump takes 12 hours. How long will it take to pump the water from the basement with the 2 pumps? The same thing. Look at the 2 pumps, they combine, it would take them t hours, okay? And then you get x times y over x plus y, where you just want to know what x is what t is what y is, right? You gotta explain it. Where x is the hour it would take the bigger pump, 10 hours, okay? Y is the hour it would take the smaller pump, 12 hours, okay? And t is the time it would take both of them. Alright, so we'll put that stuff in there. We get t equals to 10 times 12 over 10 plus 12. Okay? So it will be 10 times 12 over 22, okay? Notice that you can divide things with 2. 2 can go in here, you get 5. 2 can go in here, you get 11, okay? Alright. Can you do some more? I guess you could do some, I don't know, you cannot do no more, What is 5 times 12? That's what you have to find now, okay? Okay, that will give you 60 over 11. So that would be the same thing. If you divide 60 by 11, you can divide 55. That would be 5. And then what is it remain? Let me see. It remains 5 over 11. So this is a number of hours it would take them both, okay? You can write it like that or you can leave it like that, depending on what the teacher wants, okay? Let's move on, man. We're done with that, man. I just want to give you a flavor of the variations. The variations people make up stuff. You can make up your own variation, you see. You say Grant can completely mess up his room in 15 minutes. If his cousin Wade helps him, they can completely mess up the room in 8 minutes 8 minutes 4 over 7 minutes, something like that. 4 over 7 minutes. How long will it take Wade to mess up the room by himself? You see how they switch the stuff around? You see how they switch the stuff around, man? Both of them can, Grant can mess it up. Both of them can mess it up in that. Right? This is Grant, and then one Wade. You see? This is a variation of the problem. You see that, right? So but don't let that scare you, man. A variation of the problem means nothing. You just have to, you can still use the same formula. You see what is going on? You can still use the same formula. It doesn't mean the formula has changed. The formula hasn't changed. The formula is still the same thing. You just look, it depends on what you're looking for. If what you're looking for, based on what you're looking for, you find it. You solve what is, you put the formula down, solve what is, put what is given in there, what is not given, you solve for it. That's all. That's all you gotta do. So then, Lord, don't let this variation to throw you off. It's the same formula, okay? So let's see. The time you would take them both to do the job is t. You write t equals to x. The time you would take one person times y. The time you would take the other person, okay? And then the same thing you add it here. But we're given this here. And we're given x. You see? We're given x, so we're looking for y. So the best strategy, put what is given in there, man. Or you can solve for, if you confuse you, I can solve for y. I can remove y from there, but let's put the stuff we'll have. We'll have 8 4 over 7, okay? Is equals to, because x is equals to 15 and t is equals to 8 4 over 7. That's what you're given. You put that in there. You get, what is that, 15y over, what is that, 15y by 15 plus y, like that. That's what is giving you. Now you're going to have to solve for y. They're looking for the other thing there. So notice, this is what they call I think it's called impartial fraction. So let's put that in there. Let's put that like in what do you call that, rational expression, okay? The way you do it is, see, they divided something with 7 and they got 8. And then what is remaining is 4. They put it 4 over 7. So what you do, you take 8, you multiply 7. You get 56. You add 4 to it. That's what we did that earlier. Basically, 60 over 7 is equals to 15y over 15 plus y. So you cross multiply. I need more space, so I'm going to take space up here. You cross multiply, what do you get? I'm going to move over here. Cross multiply that, then what do you get? You get 60 times 15 plus y, okay? We're trying to get y out of there. And then 7 times 15y, okay? See it? Okay. So that's the only thing we can do. We'll have to keep going like that until we'll be able to extricate y from there, okay? 60 times 15, what do you get? You get 900 plus 60 times y is equals to, what is that? 15 times, you do 15 times 7, okay? What do you get there? You get 105y. You see that, right? So that's what we'll have to do. So we got similar things where, let's say 900 is equals to, we'll move this over the other side, it becomes negative when it gets over there, y, negative 60y, okay? So we'll simplify that. What is that? 105 minus 60. What is that? That's what you're looking for right there. You see, 45y. 45, oh sorry. It's 45y, okay? 900 equals to 45. So then you say y equals to 900 over 45. You see that, right? Then y, do that. What do you get? See? You get 20. You see, right? That's what we're looking for there. It's nothing to be scared of. So we'll knock that thing out. We'll knock it out. And I think we did it right, see? Let's see. So we'll go to the next one. What is that? An experienced employee can enter task data into a computer twice as fast as a new employee. You see that? Working together, it takes the employee 20 hours. 2 hours. How long will it take the experienced employee working alone? Notice what is going on. You gotta read carefully. There's nothing to be scared of. With the same formula will work. He says an experienced employee can do the job twice as fast as the new employee. Okay, so we know we got x and we got y in there. Remember, t is equals to x times y over, check this out, x plus y. So this is you gotta manipulate the stuff, man. That's all. T is the working together. T is here. T is 2 hours. Okay. If they work together, T is 2 hours. You gotta know what T stands for. Separately, that's the hours. Okay, but in this case, they said that an experienced worker can enter it twice faster as the new employee. So, if X is the experienced worker, right, and Y is the inexperienced worker, so it means that if the experienced worker can take X time, the inexperienced worker can take 2. Well, I'm sorry, I don't want to confuse you. If the experienced worker can take X time, the inexperienced worker can take 2X. That's what that means, man. You get that, right? 2X is equivalent to Y. That's what that means, man. You understand that, right? So basically, if we're looking for X, we're looking for that with the experienced worker, what it would take him. So make sure you understand that. So then what we'll have, they only give us two hours. So you put 2 here. 2 is equals to, notice what is going on. X still stands. Instead of Y, we'll have 2X. You see that, right? Right there. Okay. So we'll still have X, and then for Y, we got 2X. That's all, man. That's how you read that. Let's solve that. We'll solve that. What do we get? We're going to solve for X. We'll cross multiply, okay? You get 2X plus 2X like that equals to, remember this is, you can divide that over 1. It's X times 2X like that. You see? because that's it times 1, but you don't worry about that because you cross multiplying. Then simplify 2x plus 4x is equals to, look at that, turns into quadratic equation, man. It's 2x squared, okay? Oh Lord, that's okay, we can deal with it. We've seen that before. This is not new to us. For quadratic equation, you gotta, well, let's do this. What is this? I don't know quite if it's called. Combine this, you get 6x equals to, well, actually it's not as hard as it looks. Okay, if you do that, what do we do now? We'll say, let's put 0 here, move this over. 2x squared minus 6x. Of course there's 0 here, so we don't worry about that. So we're gonna solve that. Okay, notice that it's not that, forget about that 0, we don't have to put it there, you don't want to get confused. Notice something, we've done this many times in the past. We can pull out 2, let me see, we can pull out 2x like that. We get x here, we get 3 here, like that. You see it? You see what I'm doing? Equals to 0, okay? So from there, you can say 2x equals to 0, or x equals to, I'm sorry, I'm going too fast. I don't want to confuse you. On x minus 3 equals to 0. You see that, right? Notice that we don't have any restriction up there. It's okay. So we're gonna solve those two equations. But notice that here on this side, x is equals to 0. X cannot be 0, so that one won't work, okay? Because there's nothing like 0 time here. It's nothing like 0 time doesn't apply here. So he said then x equals to 3. This is what we're looking for. I hope you understand what I did. I didn't do any magic. When you get x, we're looking for time. Time cannot be 0 because that person gotta spend some time solving the problem. I hope you understand what I just did. Don't get confused. Just go over it. Then you're gonna understand what I just did. So it would take the experienced employees 3 hours. That's what that means. Let's interpret that. It would take experienced employee, let me see, hang on, you gotta write that, right? Experienced employee, okay? Employee would take 3 hours to do the job. That's what we're looking for here, because remember the condition here. This is belong to experienced employee, okay? All right, and then the other person will take, working together they take 2 hours, okay? So if you want to know what the other person would take, if they work together, it would take them 2 hours. T is 2 hours. This is x. T is 2 hours, okay? And then what is the other guy's hour? It would take him double, right? So it will be 2x, which is 2 times 3. That's 6 hours. The other guy would take 6 hours, okay? 6 hours. That's all that is saying. That's the way you interpret it, okay? And then I'm done with this problem. We'll move on. Okay, let's look at this one. This is the last one I will do under this type of problem, okay? Notice there's a reason why this one is important. I need to use it to explain something to you. You remember the formula we've been using, T equals to x times y over x plus y. Time is time, right? Time they would do, T is time they will use to do it jointly. Time can be anything. Time can be in seconds. Time can be in minutes. Time can be in hours. Time can be in days. Time can be in weeks. Time can be in years. So you just take what they tell you in the problem. Look at this one. It says one roofer can put a roof on a house 3 times faster than another roofer, right? And they say working together they can roof the house in 4 days. Well, a house in 4 days. How long will it take the faster roofer working alone? Notice that T is in days. It's not in hours or minutes, but it's in days. Keep that in mind. Okay, but you need to also, this is similar to the problem we did before. It's similar to this one that they're talking about in hours. Okay, this is the number 20, problem number 20, talking about hours. This one talking about days. Okay, so keep that in mind, but it changes nothing. That's why the way we got the formula is good. We say time for them working together is like this: x times y over x plus y, where x, in this problem here, x is the number of the amount of time you would take the first guy working alone. Y is the number of amount of time you would take the second guy working alone. Okay, that's clear now. We got that. T is the time it would take them working jointly. So let's get out of the way. But look at let's read the problem. It says the first roofer would put a roof on the house 3 times faster than the second roofer. So that means, see, they give you condition here. That means the first roofer will take x time to do the roof. Then the second roofer will take 2 times. What is that? Say 3 times. So you gotta understand what they're saying there, man. First one will take x time. Second one will take 3x. That's all. What they're saying, x stays, y is equals to 3x. That's all. Make sure you understand that. That's the first condition. The second condition is t is equals to 4 days. Okay, in days. Okay, you see that, right? Now they're looking for the time you would take. They're looking for x time you would take the faster roofer, because the faster roofer goes very fast. That you will take him 3 times. He will go 3 times faster than the second roofer. See that, right? Make sure you understand all these variables. We'll put them in. Make sure you understand what each stands for. So basically, if we use this, put in there what we get, and we'll put this in there too. You know, we're working in days, right? Not in the hour, in days. Let's put that in. What do we get? We get 4 days here is equals to x. X stays the same, but then y changes. Y changes to 3x. That's all. And then x stays the same here. Y changes to 3x. Make sure you get this, man. Go over this many times until you get it. It's nothing to be scared, you know. That's what they're saying. We're doing what they're saying, you see. Sorry, I'm messing with this stupid thing here. What is this? This is x. Make sure you get what they're saying, you see. That's our setup right there. That we're gonna solve for this. Remember, we can do 4/1. So we got plenty of space. So let's hack this thing out. It goes 4 times cross multiply 4 times this quantity here equals to x times 3x times 1, you know, so you move times with 1. So we simplify 4x plus 12x is equals to, what is this, 3x squared. You see that, right? 1 disappears. See, 1 gets sucked in, 1 doesn't do anything. See that, right? So let's keep simplifying. What is this? This is 16x equals to 3x squared. There are many ways you can solve this, but I want to do it the proper way. If you're in a hurry, you can cancel stuff out and move on. You know, you can cancel x on both sides, but let's not do it that way. Let's do it the way we've been doing it. That way I don't confuse you. You can say 0, move that thing from the left, move it to the other side. You have 3x squared minus, sorry, I'm going too fast, minus 16x, okay? So I can rewrite the whole thing, 3x squared minus 16x equals to 0. I didn't change anything. I just move things around. That's all. Make sure you understand what I'm doing. So we gotta solve this. We'll pull things out. What can we pull out? We really don't have much to pull out. We can pull x out. We get 3 minus 16. I'm sorry. Going too fast. Pull x as 3x minus 16 is equals to 0. Notice something. So you say x equal to 0 or 3x minus 16 equals to 0. See that, right? Notice that time cannot be 0 here. So this doesn't work. Because he can't take 0 time to do the work. This is a guy working for. There's no way he can do it in 0 time. If he does it in 0 time, then he didn't do any job, you see. So, but anyway, and we're talking about days now. So this is our solution here. This one here. Let's solve it out. 3x minus 16 equals to 0. Okay, 3x equals to 16. X equals to 16 over 3. Now, notice we're dealing with days, right? Okay, this is days. Notice we can live, we can leave it like that. That's what our teacher wants. But we can, if 3 divide 15, what do you get? 3 will get, out of 15, it will get 5 times. And then remains 1 time over 3. You see that, right? Because he said 5 times 3 is 15. 15 plus 1 is 16. So it will take 5 days and 1 over 3 days. So that can be worked out. These are days, okay? That can be worked out. Okay, so if you want to go back, this is the faster worker now. Notice that that's the faster worker. This is the faster worker, okay? Because he would take 3x. It would do 3 times faster than the slower worker. If that's the case, then the slower worker would take, you see right here, the slower worker would take, if they want you to find out, slower worker would take 3x, that's 3 times 16 over 3, okay? That guy would take 16 days, man. That's what that means. If they want you to find out the slower worker, he would take, I'm sorry, I didn't, that's that's why. He would take, multiply that, he would take 16 days, man. You see that, right? He would take 16 days, while the other guy would take 5 days and 1 over 3. 5 and 1 over 3 days. That's what the faster guy would take. So I'm done with this problem. If you don't understand it, leave question, but I think I know I did it right. You just have to follow this formula, okay? The formula can be used in any variation. Alright? The variation, these are for 2 workers. Like I said, there might be variation for 3 workers, 4 workers, 5 workers. I will get to that. Because, I'm still going to come back and solve problem. Like I told you, I saw a problem now to demonstrate the concept. Then I think I'm going to move on. I'll have one more topic before I go to Algebra 2. But that doesn't mean I'm not going to come back. I may come back next 2 years and solve more problem under Algebra 1 and then post it. Let's say, 1 year from today, I'm experimenting with working with 4 workers, 6 workers, 10 workers. I figure it out. I can come back and post something on that, okay? So, but let's move on to a different type of problem here. Now, we're switching to a different kind of problems, okay? This time we're going to deal with distance, rate, and time, okay? Rate of change. I hope you know that rate of change is the biggest concern of calculus. Rate of change, okay? But we'll get to that. We're going to get to calculus sooner or later. Okay, look at that. We solved a problem like this before. It says the river has a current of 4 kilometers per hour. Find the rate of J's boat in still water if it travels 40 kilometers downstream in the same time that it takes to travel 24 kilometers upstream. So they have upstream and downstream. We did stuff like this before. You got the current. The current is in how fast the water is going. Like I said before, when he goes downstream, the current helps him move faster. Okay, when he goes upstream, the current kind of is like a retardant force, like what they call frictional force. All right. So you need to keep that in mind. And then I explained this thing for you. This still water thing. The still water means there is no other forces like too much wind or a tornado or anything, any natural event that causing problem. You see, so that's all that means, man. And then remember that I told you this kind of problem, it has to do with rate. Okay, the general formula you need to remember is rate is equals to distance over time. That's all. So if you're looking for distance, you cross multiply. If you're looking for time, you cross multiply. Okay. So, but look at there are two situations. You say the rate of the still water if you travel downstream in the same time. The time is the same. Okay. And they want us to find the rate. Okay. We are looking for the rate. So now notice there are two ways you look at the problem. Downstream. Okay, when it goes downstream and when it goes upstream, okay, those are two. Downstream and the upstream, okay. When you're going downstream and when you're going upstream. So what you do is say let x be the rate we're looking for. Find the rate of just boat. Be the rate of the boat, okay? Rate of boat, okay? And then when it's going downstream, it's using the the current of the water is helping the boat. So it has x plus 4, okay? That's the rate is going down. You have to add the rate of the water to the rate of the boat. But when it's going upstream, you have to subtract the rate of the stream, because the rate of the stream acts like a retarding force. So the boat have to actually use more gas and more force to go up, okay? So this is the rate upstream, downstream, rate upstream, okay? Those two rates has to be equal. Well, the time, they say the time is equal, right? That's what they say. From here, what is the time? Time is from there, t is equals to, right? Equals to d over r, okay? You see that, right? It's cross multiply. Since the time are equal, time here, time upstream, distance over rate, okay? And then notice they gave us the distance. The distance for downstream is that. Distance for upstream is that, okay? So basically, we're given this. That's what we're given. Distance for downstream is 40 over x plus 4, okay? And distance for downstream is 24, okay? X minus 4. That's all. So because the time, it says the boat still if it travel downstream in the same time. So you equate those two because they're the same time. Because so this is time downstream, this is time. Alright, since the time is equal, so we equate those two rational expression, okay? So 40 over x plus 4 is equals to 24 over x minus 4, okay? And then we'll cross multiply. You cross multiply, you get 40 times x minus 4 is equals to 24 times x plus 4. That's all. So we're going to solve that. Solve that for x. Once you solve it for x, we'll get that, okay? Let's solve that. Actually, I didn't give myself enough space. Don't worry, I'm going to make space now. Okay, so we'll solve that. What is that? we multiply things out, we get 40x minus 160, okay, is equals to 24x 96 plus 96. Alright, so you gotta move things around. We say 40x, bring 24 over here, minus 24x is equals to, take 160 the other side, it changes sign, plus 96. You see that? So we'll combine the left side. You combine the left side, what do you get? You get 40 minus 24, okay? You get 16x is equals to, you combine that over there. Okay, 160 plus 96 is equals to 256, okay? So you say x equals to 256 divided by 16. What is that? It says 16. Alright. So x is 16. The rate of both, right, is x. So we found it. The rate of both is 16 kilometer per hour. So the rate is x equals to 16 kilometer per hour, okay, per hour. That's what they're looking for, okay? Make sure you understand what is going on there. Okay, so we'll leave that and we'll move on. Okay, here is the next problem. It says an airplane maintaining a constant airspeed takes as long to travel 450 miles with the wind as it does to travel 375 miles against the wind. If the wind is blowing at 15 miles per hour, what is the rate of the plane in still air? Okay, this is the same problem we just solved. It's the same thing, they just rewarded it and give us different numbers. Okay, so there is still air. Over there was a still water, okay? Over there was the plane is moving in still air. Over there, the boat was moving in still water, okay? Okay, over here it says it gives us the speed at which the plane is traveling with the wind. Remember, the boat was traveling downstream with the current. Now downstream over there, the boat is with the current, all right? Here, the plane is traveling with the wind, okay? The wind is helping the train to move. So, the plane is using the wind, and the wind is 15 miles per hour, okay? And then it says, remember, they look at that, it says constant airspeed. It takes as long to travel 450 miles per hour with the wind as it does to travel 375 miles against the wind. So with the wind and against the wind, the time is the same. So just the mile travel is different. Do you understand? So there is a retarding force here. Okay, so there are two things here with the wind. Okay, the wind is helping. Okay, and then against the wind, the retarding force against wind, okay, and the time is the same, so it's the same thing. So we're gonna have to use this. You remember I said that rate is equals to distance of time, but time is the same, so we got time equals to distance over rate, okay? So this is gonna be the same for both of them since the time is the same. So for this one, with the wind, that means basically if we let's say let x, because that's what we're looking for, let x be, what is the one that's the rate of the plane in still wind. Let x be the rate of the plane in still wind, okay? Be the rate. Be rate in still wind, okay? That's what we're looking for. So then with the wind it means plus x plus 15, and against the wind x minus 15, okay? And then when you use this formula, d over over R is the same thing for both of them, because that's time. Okay, so that's this formula here. I'm sorry, that's this formula here. All right, so that's time. So with the wind, the time is, I'm gonna write it over here. With the wind, the time is distance over rate. The distance is given 450. That's with the wind. Okay, so it's 450 over the rate, which is that. Okay, against the wind is 375 over x minus that. You see that, right? So both of them are equal because the time is equal. See, these are time. This is time here. This is time here. Okay. So the two times are equal because that's what the problem says. So you equate those two and then you solve. 450 over x plus 15 is equals to 375 over x minus 15. Okay, you solve. You cross multiply. All right. You have 450 times x minus 15 equals to 375 times x plus 15. Okay, you see that, right? Okay, so we just have to work with big numbers, man. That's all. We're gonna work with big numbers, so we'll multiply it out. Okay, if you multiply it out, that's what you get there. You get you get that expression there. So you have to move things around. So you say 450. Let me see if 450x minus 375x is equals to 5625 plus 675. Oh, that's all. You add all this to get simplify that expression. What do you get? Okay, so when you simplify, you get that, and then you divide. When you multiply, let me see, you multiply things out. No, when you add this, you get that, and then you divide, you get that. Okay, I was interrupted, so sorry about that. But that's what you get. 165. That's the answer. Okay. Now remember that thing is 165 is in mile per hour, and that's the rate of the plane in still wind. Okay, so that there's the rate of the plane in still wind. Okay, my pen is not writing, so that's the rate of the plane in still wind. Okay, all right, we're done with that. Let's move on, man. All right, here is our next problem. It says Connie's boat travels at 12 miles per hour. Find the rate of the current of the river if she can travel 6 miles upstream in the same amount of time it takes her to travel 10 miles downstream. Okay, so same thing applies, man. Let's just switch what they're looking for. Remember, time is the same. Time is distance over rate. Okay, all right. Well, we have to use the idea of downstream and upstream. What we're looking for, we'll find the let x be the rate. Okay, be the rate of current. Be rate, not rate of both, rate of current. Okay. Okay, rate of current. All right. So we got the rate of the boat for both upstream and downstream. And then what happens when you go downstream? The rate will help. See, downstream, let's do it like this, man. I don't want to be writing all that. Well, yeah, I have to because it's the same if I'm abbreviate it, we get confused with that. Downstream, upstream. Okay, we'll write it out. I don't want to be lazy. Okay, so what is going on downstream? The current, we're looking for x will be helping him. I mean, helping Kanye is a woman. Helping will be helping her, right? So you're gonna actually have we have rate. Okay, we have the rate here. The distance travel is done. The time is the same. So somehow we're gonna equate this for downstream and this for upstream. Okay, so what do we have? We have distance. We have distance travel. Distance travel is 10 for downstream. Distance travel for upstream is 6. All right. So the rate here has to be, let me see, is 12 for Canis boat plus the downstream has X included, helping. I mean X helping to push it downstream. But over here the rate is 12 minus that. So but those two are equal. 10 over 12 plus X is equals to, sorry man, I'm getting sloppy. I think I'm getting tired. It's equals to 6 over 12 minus X. I think that's what they want us to solve, man. So let's cross multiply, okay? So you get 10 times 12 minus X equals to 6 times 12 plus X. Alright? Okay, so you multiply that. What do you get? You get 120 minus 10x, okay? It's equals to 6 times 12. So that's 72 plus 6x, okay? Now you gotta shuffle things around, okay? 120 minus 72 is equals to 6x plus 10x. Okay, so what is that? Move things around any way you like. It will be 16x equals to, that's 48. Okay, x is equals to 48 over 16. You see that, right? What is that? 48 over 16. So that's 3. So what is that then? It's miles per hour. That's the current. Mile per hour. That's the current, okay? The current of the river. That's what that is, okay? Okay, here is the next problem we have there. It says, I'm gonna read that. Mohammed's boat. Mohammed got a boat. Mohammed's boat Mohammed can travel, not boat. He can travel 8 miles upstream in the same time it takes him to travel 12 miles downstream. He has a boat. His boat travels in 15 miles per hour in still water. What is the rate of the current? Now we're looking for the rate of the current, okay? It's the same thing we did over there. You see, I tried to formulate it this way. If it helps you, use it. Don't help you, don't worry about that. Downstream, the rate is that. The time is that. Upstream, the time is that. Then you gotta formulate this stuff here. Downstream, D over R is equals to, what did they give us? The upstream is 8, downstream is 12. Distance is 12 over, what is that? The rate, what is the 15 miles per hour is the still water. Okay. It's 15 plus x. We'll let x, you see, we'll let x be rate of current, okay? You always want to stipulate that way you know what you're solving, because that's what they want. Okay, but the current will help him go downstream like that. Upstream he will have a drag force. What they call is different. They call it different things in different subjects. In physics, they call it frictional force. The current will produce a frictional force, and they will retard the progress of the boat. So whoever driving the boat will give more gas and use more force. So that's what is that, 8? Yeah, 8. My distance travel 8 over 15 minus x, okay? And then both of them are equal, see? That's what I say here. They're equal. Upstream and downstream, they travel the same time. So it's 12 over 15 plus x equals to 8 over 15 minus x. That's what we gotta solve. Cross multiply, you get 12 times 15 minus x equals to 8 times 15 plus x. That's all. You see that, right? Okay, you multiply that. This is what you get. Okay, so you move things around, you get 180 minus 120 is equals to 8x plus 12x. Okay, yeah, okay, fine. Let's do that. You do this. What do you get? You get 60 is equals to 20x. Yeah, so you can say x equals to 60 over 20, and that will give you 3. So x equals to 3. What is that? 3 miles per hour. That's the rate of current. 3 miles per hour. Okay, is the rate of current, and we're done with that. There's nothing else to do. All right, I think I'm gonna end this thing here. Please subscribe to my channel, like and share this video. If you have any question, leave it under the video. I will answer them. Okay, thanks for coming. I will see you in the next video. I think next time I'm gonna do let me see, I need to touch on complex numbers, you know, the roots. I think it's called let me see, I'm gonna deal a little bit because we haven't dealt with that here. I'm gonna go ahead and treat the roots, radicals, and root functions. Well, no, stay away from the word function. We're gonna deal with that in algebra 2. So next time I introduce you to roots and radicals. That's it. Okay, forget about the word function because intentionally I left that out. We'll deal with that thoroughly when we get to algebra 2. Okay, this is just introductory algebra 1. All right, thanks for coming. I'll see you in the next video.